In this video, we're going to work an example using fractional conversion and extent of reaction to actually solve a material balance problem. So, in this one, we have the Deacon process. It's a way of manufacturing chlorine using hydrochloric acid and oxygen. We want to provide air, not just oxygen, but air, which is 21% oxygen and 79% nitrogen. And we want to feed it so that we have 25% excess oxygen. If I have 1 pound mole of HCl per hour fed, my first question is, how many pound moles of air per hour will be required? So I'm going to set that up as my basis. And I'm just going to create a simple little material balance table over here. I have one stream in, one stream out. I'm not going to bother drawing the picture in this particular case. So I have one stream in, one stream out. The feed does not contain any Cl2 or H2O, but it's going to contain HCl and air, which is oxygen and nitrogen. So if I want to know how much oxygen is required, well, that's based on the stoichiometry of the stoichiometry, of the reaction. So if I have 1 pound mole per hour of HCl needed, okay, then for every 4 moles of HCl, there's 1 mole of O2. So just simply set up the proportions so that the HCl's cancel top and bottom, leaving me with moles of O2. So then that would take on the units of whatever I started with. So in this case, 1 pound mole of HCl per hour. So I'll have 1 times 1 divided by 4, so 0.25, and the units are going to match whatever my rate of O2 was, pound moles per hour. So I can then use how much is required with my definition of excess. I want 25% excess O2. So fractional excess is 0.25. That's defined as the number of moles that I have minus the number I needed divided by the number I needed. So subtracting and dividing the 0.25 required, I end up with 0.3125 pound moles per hour that will actually be fed to this reactor. So I have one more component, and that's the nitrogen. How much nitrogen is fed? Well, it's in proportion based on what the content of air is. So for every mole of air, there's 0.79 moles of nitrogen, 0.21 moles of oxygen, if you're rounding to 2 sig figs. And so here I've just used that little proportion to find out that I need 1.1771 pound mole per hour. Again, notice in every case, I could work these problems by simply looking at them as a unit conversion problem. If I always consistently write pound moles of O2 or pound moles of N2, don't just write moles. Moles of what? And if you do that, you will consistently get correct answers. So my total amount of air fed, which was what was asked for in this case, just add those two up, I get roughly 5 pound moles of air per hour. So roughly 2.5 pound moles per hour of total feed. Now, if the fractional conversion, so new question, fractional conversion of HCl is 70%, I want to find how much is in the exit stream of everything. So let's start with looking at the HCl. So 70% is going to react. So 0.7 pound moles per hour will react. That means 0.3 don't react. So I'll have 0.3 pound moles per hour leaving the reactor. If I continue using stoichiometric proportions, okay, so 0.7 reacted, and 1 O2 reacts for every 4 that react for oxygen, then I can get this equation for oxygen. Nitrogen doesn't react, so it stays the same. And Cl2 and H2O, they came in with nothing, but for every mole that reacted, 1 mole was formed. I guess I could have said 2 over 4, but 1/2. And I end up with 0.35 as my exit flow rates. Notice that the flow rate at the exit is different for the two. The mass balances, but the number of moles changed because the number of moles in my original reaction changed. I have 5 moles in, 4 out, so the number of moles coming out decreased. Now, one last little question: what's the extent of reaction? Well, just take the HCl, since that was the one that was defined. I could use any component, but that's going to be the one that's easiest. Well, okay, I couldn't use nitrogen. But what comes out is equal to what came in minus the stoichiometric coefficient times the extent of reaction. So solving for this, I find that the extent of reaction is 0.175, and I could use that with any of these and I would still get the same answer. So that concludes our videos for this week. Thank you for paying attention. Next week we will begin looking at equilibrium.